Today I'm going to be assembling this mini Fun Cub model. In the background there you can see a genuine multiplex Fun Cub, which is somewhat larger but infinitely more expensive. The retail on that guy is somewhere around €300. You can pick up this for around 50. And is it going to be any good? The similarity is incredible, even down to things like the exhaust manifolds there. I'm sure this kit has absolutely nothing to do with multiplex, but as copies go, it's about as close as you're going to get. Similarly, the wings that are supplied have the ailerons cut out, but the flaps are optional as on the larger multiplex Fun Cub. We'll see how it flies and then maybe elect to put the flaps on afterwards. The two wing sections being held together by a supplied carbon fibre rod. To power the model, I've bought an El Cheapo bundle comprising a motor, speed controller, 2 servos. It came with its own propeller. After some deliberation, I've elected to go with this 8x4. The prop adapter was supplied as well, and there's a review of that bundle that I've done previously. I'm intending to use this Turnigy Nanotech 1.8 ampere hour 3-cell pack. Being a big fan of telemetry and probably annoying my fellow club members with my strange transmitter announcements, I'll be using this Radio Link R8F 8-channel receiver. I've gone ahead and extended the servos both for the ailerons, and the servos are located at the back for the elevator and rudder. My preference is to solder those connections on rather than use extension leads, which I find to be bulky and possibly another source of a bad connection. So I've gone ahead and soldered those. Without further ado then, let's start the assembly. Rudder and tailplane assembly, very straightforward. Tailplane locates into another plastic piece there. Pay attention when attaching the rudder, as the tail wheel needs to go into this hole here, and you may even need to open that out. That then sits on there, and in the supplied hardware is just this one long self-tapping screw that will hold it all together. I think I will take the added precaution of putting just a dab of foam safe glue in this area here with belt and braces to make sure it all stays together. When fitting the servo for the rudder, I encountered 2 challenges. The first is how to thread the servo cable through. It's a rather tortuous maze through here. I managed to get a piece of fishing line through that I can pull the servo cable through on. I found this miscellaneous bit of metal hardware, and I just dropped that through and give it a shake around, and that eventually dropped out the bottom. The other issue is that there's not enough depth in there for these particular servos to sit flush. They were standing proud by about 2 millimeters. I couldn't really glue them then. My solution was simply to print a spacer up on my 3D printer. I've got a couple of those, one for the other side. Simply fit in like so. I'll glue those in and then glue the servo on top. We'll do that on this side now. Now I can feed the cable through. You don't get very far before it fouls on the servo hole on the other side. Just need to push that. With the other side clear, we can then go ahead and pull the rest of the servo cable through. Now I like to keep the control rods as short as possible, so I'm going to put my servo in this way round with the horn closest to the control surface. I'd already gone ahead and glued the control horn in the rudder, and now hopefully you can see that the servo is flush with the top of my little spacer there. I'll go ahead and glue that in place now. I'll just gently clamp that in place whilst the glue sets up. One very important thing that we must do with all servos, especially on the wings before installing them, is to make sure that the arm, when at the center frequency, if you will, 1500, is as close to 90 degrees vertical as we can get it. We need to put the screw in there, and once it's glued in place there, it will be very difficult to adjust. Just make sure you do that, and that will enable our control surfaces to be at neutral. Finished the installation now of the servo. Just put a little bit of painter's tape on the bottom of the servo and then glued it into place. Put the control horn in and the stopper there. Run my cable. I lifted this decal off. Came up pretty easily. You may need to use a very low heat hairdryer or something, but it just lifted straight up and stuck straight down again. These stickers seem to be fine. The ones for the windows definitely leave something to be desired. We can worry about such things later on. Important thing now is to get on with the build, finish the other wing off, and then we can get everything plugged into the receiver. Things really coming together now. I've just temporarily put the receiver on the top there so that I can check the direction of all the control surfaces. No problem there with the ailerons. I have set up some rates on those as well.
Aileron rates 50%.
Which I think we're going to need.
Aileron rates off.
Similarly with the elevator, that's all going correctly. And indeed the rudder.
Throttle active.
Don't worry, no propeller on there. Seems to be making the right kind of noise. And
12.3 volts.
As we can see there, in agreement with the telemetry coming back from the receiver. All is good then. Now that I've checked that everything is working, I will put the receiver in its proper place, and most importantly, check for the C of G. This being a trainer type, it should be about 1/3 of the wing chord, which translates to about 50 millimeters or 2 inches back from the leading edge. I'll get on and do that, and then we will wrap the video up. The motor is simply screwed to the motor mount, and it has built into the motor mount a little bit of right and a little bit of down thrust to compensate for the propeller torque. Past the wires for the motor in through the cooling grid there, and the cowling just clips on the front with the little magnets there. Quite a neat arrangement. Plenty of room for the propeller to sit on there. It's not going to foul anything. Things are not very tidy inside. This is the lead obviously for the battery voltage telemetry, and I want to keep the receiver up out of the way so that there's airflow over the battery area and the speed controller. What I've done then is to print a little tray for the receiver to sit on, and that will just push fit inside the fuselage there, and there's double-sided sticky supplied with the receiver, and that will sit up out of the way. Links to both this and the little shims for the servos I will supply in the description below. We're finally there now. Things a little bit snug inside here. You can see my 3D printed tray in place with the receiver stuck to it, and you can see in the bottom there the speed controller. I've added a strap for the battery. Fitting the battery is a little challenging, not too bad I suppose, considering the space restrictions, so you can push the battery through there. Once it's in place, rotate it and just push it down to the bottom there. That strap should keep it securely in place. And my battery connection there, so that is all good. How about the centre of gravity? I've put marks either side at the 50mm mark. Place my fingers there now. You can see that the craft has just a very slight nose down attitude. A little bit nose heavy, that shouldn't be a problem. We've got plenty of room to move the battery back should we need to. There she sits then, looking pretty. Like Dickens, I have great expectations. If it flies anything like its big brother, then I should be well happy. Maiden flight coming up soon. Thanks for watching.